STEREO is a mission to help us understand what we call space weather, how the activity on the sun can affect us here at Earth. The sun will blow out what we call coronal mass ejections. They're a kind of solar storm, 1 billion tons of matter coming at us at 1 million miles an hour. And they can affect our technology here on Earth, affect power systems, affect spacecraft. And so understanding them is not just a case of their scientific interest, but it also has practical application. These two spacecraft are giving us two views on the sun instead of just one. And that's really important because the structures that we're looking at the sun, that are in the solar wind, which is the sun's atmosphere blowing out into space, really three-dimensional objects. And to really understand what we're seeing, we have to look at them from more than one point of view. CMEs, looking at them, they're kind of like big puffs of smoke. They have structure, but you can look right through them. In general, you can sort of think of CMEs as a kind of big bent slinky. And by looking at it from more than one point of view at the same time, we were able to confirm that that's roughly what CMEs look like. The sun's super hot atmosphere is flowing out into space constantly, and this is called the solar wind. And coronal mass ejections are kind of like storms in the solar wind. We can see from a distance the large scale of these storms blowing out into the solar system, but we can actually sense in a number of locations throughout the solar system, STEREO and other ones, the actual disturbance as it goes by. So we can sample the solar wind, see what that's like, sample the CME as it goes by, and putting all those together, the remote sensing data, the local conditions, have given us a really good, complex picture of coronal mass ejections that you can't really get from a single spacecraft. Comet tails respond to the solar wind, and we've known that for a long time. They're basically charged gas, and they're interacting with the magnetic field in the solar wind. But what we see here is all the dynamism in this tail. And you can see that it's not just sort of a straight tail, but that it's responding. You see there, right there. It's responding to this coronal mass ejection that's coming out from the sun. So it helps us understand how the comet interacts with the solar wind. We can actually use the comet sort of as a way to probe the solar wind. So STEREO allowed us to see the far side of the sun for the first time. You look at the sun and you see these bright regions, these active regions. That's where things like solar flares occur, and really big coronal mass ejections will often come from near those. You might not see anything on the side of the sun facing you, but something really interesting might be developing on the far side of the sun. It can be a surprise when it comes around. You know, we might have some inklings that something's going on back there, but we can't really see it without, for instance, STEREO. So this was a major, major solar storm. We would have known something had happened, but we wouldn't have understood its magnitude just from data on this, from the point of view of the Earth. And if you look in the coronagraph image to the right, you'll see that suddenly there are all these little bright, like bits of snow that show up on the detector. Well, those are called solar energetic particles. And what they are particles that are accelerated almost to the speed of light. And those can be quite hazardous to, for instance, spacecraft or astronauts. They are related to these coronal mass ejections and other kinds of solar activity called flares. And we would never have even known that it was happening without spacecraft on the far side of the sun. So by putting all these different points of view onto the sun and space weather, we've been able to understand our star in a way we've never been able to understand before.